Hi, so here we have a MacBook Pro late 2013 15-inch with a 920-3662 board. There are two issues with this board. The first one is that we don't get any internal display, and the second one is that the camera connector is damaged, so we can plug in the camera cable. So the second one is nothing but replacing the camera connector. First one, we are gonna have to do a little bit of troubleshooting on the display circuit. So we are gonna plug in an external display on the HDMI port. Okay, let me plug in the MagSafe as well. Okay, so the machine is turning on. But there is no display, so I'm gonna show you on the external display. As you can see, we get an Apple logo. Okay, so we are booted. Let me type in my password. One thing we can already see is that the external display is used as the main display. So most likely the internal display is not recognized, so we can go into parameters and displays and see that we can only see the external display. Same if we go to displays here, we only see our external display. The internal display is not recognized at all. So it's not just a backlight problem, but also an image problem. We don't see anything on the internal display. So for this we are gonna have to troubleshoot the display circuit. The first thing to do in this case is to check the voltage going to the panel. So while troubleshooting this issue, you need to have the panel connected and preferably the computer open, because if we close the computer, the LED sensor will detect that it's closed and turn off the internal display, which is expected. What we're interested in is the display circuit, so we have the display connector right there. We're gonna very carefully open the latch of the connector and do not unplug it while there is power going to the board. So here it's turned on, the MagSafe is connected, the battery is connected. If you want to unplug the LCD connector, you need to unplug everything, MagSafe, battery, no power at all. Anyway, for now we are gonna unplug the external display, we don't need it because we want to troubleshoot the internal display. And what we are gonna do is take a look at the board view right there. This is our LCD connector, and if we take a look at this connector, we have the backlight rail here. We expect that it's not present because the LCD is not detected, but we also have on the bottom the power rail for the LCD itself. So on the schematics, this is pins 28, 29 and 30, which are here. 28, 29 and 30 comes from this power rail, goes through the inductor and is enabled by this chip here with the signal coming from the CPU. So this is a 5 volt rail, so if we measure on these 3 pins, we expect to see 5 volt. Okay, voltage, let's pick a ground point. So we want to measure on the LCD connector the pins at the bottom here. We have 0 volt, so the display doesn't receive power at all. If we go just a little bit further back, you can see on the board view that it goes through this inductor. You can measure here as well, which is a little bit easier. Inductor here. And we have 0 volt as well. So there are multiple reasons why we could have 0 volt here. So one thing to know with this board with integrated graphics on a display port, embedded display port, is that the 5 volt rail will get disabled if the display isn't recognized. So while the machine is turning on, you will see the 5 volt rail for a few seconds. It allows the display to initialize, pull up the hot plug detect signal, then the PCH or the CPU rather will read the ED-ID through the aux channel here. If this doesn't work, then the 5V rail will come down. So what we are going to do here is measure while the machine is turning on. So I'm going to turn off the machine. I go on here. I'm going to measure same on the inductor here. Okay. I'm going to turn on the machine. As you can see, the 5V rail for the LCD comes up, then it goes down again. So the LCD hasn't been identified. So in this case, we measured before the inductor. We are going to do the same thing after the inductor on the LCD connector itself. I'm going to turn on again. Fan is spinning. And we measure here only 1.8 volts. So there is definitely something wrong with this power rail. So this is expected that the LCD cannot get identified if it doesn't receive the proper voltage. So the only thing between the two measurements that's different is that we have an inductor in between. So just to clarify, this is inductor L8300, which is here. So maybe this inductor is bad, so what we are gonna do is unplug our MagSafe, unplug the battery. Okay, make sure the computer is discharged, okay. And now we are gonna put our multimeter in resistance mode here, and we are gonna measure this inductor. As you can see, the inductor measures around 6.3 kilo ohms, which isn't right. It should measure close to 0 ohm. So this is definitely a bad inductor, even though it looks perfectly fine. So I'm going to show you after taking out the board from the case under the microscope what it looks like. Okay, so there is our board under the microscope. So this is the LCD connector right there, and the inductor right here. So as you can see, it looks literally perfect, except for the probe mark which comes from me. But anyway, we measured it and it's bad, so we're gonna have to replace it. So we're gonna take our soldering iron and we're gonna apply some solder to the inductor. Let it solder. Okay. Now it should come off. Great. And now we are gonna take the inductor from a donor board. So I don't have a 3662 donor board, but I have a 3476, which is the 13-inch variant, but the inductor right there is the same. So if you take a look at the schematic, L8300 is also 805 220 ohm impedance, which is the same thing as ours. So it's good to take from this donor board. This is our donor board. We are gonna do the same thing. Okay, so this is a good inductor. Great. Let's go back to our patient. So I'm gonna switch tip to have more control over what I'm doing. I'm gonna use some solder wick. Clean up our pads. We are gonna tin the one pad. Okay, and put the inductor there. Okay, I think it's aligned properly. Let's solder the other pad. Okay, and let's put some flux on top to make those solder joints look a little bit better. Okay, we should be good. Let's clean that up a little bit. Okay, looks perfect. Now we are gonna put back the board into the machine. We are not gonna apply power just yet because I want to check something. Okay, so here is the board back into the chassis. So what we're gonna check now is two things. First thing we are gonna check is if our inductor measures good now. So let's check the resistance across the inductor. As you can see, we get 0 ohm, which is perfect. And the second thing to check is that we need to make sure there is no short to ground on the output. So if we check in the resistance mode, we see 11 kilo ohm, which is most likely fine, and there is no short to ground. I also inspected inside the LCD connector to make sure there is no problem there, and everything looks perfect. So I think the inductor died because someone unplugged the LCD connector while there was still power going through the board and shorted the 5-hour power rail for the LCD to ground. So now that we made sure everything looks okay, we are gonna turn on the machine and see if we get an image on the internal display. So I don't have an 85 watt MagSafe, so that's why I have to plug in the battery. Okay. And as you can see, we get an Apple logo. So the board is fixed. For this issue anyway, we still have to replace the camera connector, but it's not a big deal, so I won't do it on camera. Okay, so now if we check into the displays, we indeed see the integrated Retina display. And same in parameters, we see the integrated display. So just as a sanity check, we can now measure the voltage on the output. So in voltage mode, we can now check that we indeed have 5 volts before the inductor, 5 volts after the inductor, and 5 volts on the LCD connector pin. So everything is as it should. So that's it, and we see you in the next one.